Good afternoon, everybody. I understand this has been a long day. We are delayed by an hour. Please bear with us for the delay. We are here. We welcome you all, my colleagues, the industrial partners, the fellow professionals. Our topic for the panel discussion today is transforming ground improvement practices through advanced characterization and smarter material selection. We all know the demand for the infrastructure is increasing day by day, and in current race of mega projects going on in the Middle East, this has become a necessity to innovate what is the best solution to see the characteristics of soil. As we know, any structure, any project is mostly which is on land. It needs a soil investigation to understand what the design would be, how the characteristics will develop during the design stage, and how it behaves. To do so, it's important to see what are the best solutions in the market today to deal with all these challenges. We have seen projects getting hold because of the unforeseen underground situations which were not taken into account during the design stage. However, times have changed. That has been addressed to a lot extent, and anything further that needs to be done, that's being looked at. We have gathered a panel of experts who are from the industry of geotechnical design and projects execution part. Myself, I'm Shabir Hamadani. I'm Projects Director, Saudi Real Estate Infrastructure Projects, infrastructure company. I'm from Saudi Arabia, Riyadh. With me is Mr. Rahul. I'll request everybody to introduce himself and give us the background, which industry they are and how they are, what are they looking at, basically.
Good afternoon, everybody. Myself, Rahul Sai Nambiar. I'm the engineering director with Pinnacle Piling Foundation. And we as a company specialize in piling foundation solutions, shoring, ground improvement, and soil engineering in general. And we have our offices here in the MENA region and also India as well. And we have a fleet of a lot of machines and engineers who have been working on providing ground engineering solutions all over.
Good afternoon, everyone. My name is Thanawat Shulakiat. I'm a regional practice lead from McDonald. Similar to Engineer who we have offices in UAE, Saudi, and across the Middle East region.
Good afternoon, everyone. My name is Georgios. I am head of engineering at Bin Laden Contracting Group. Quite new, about a year ago I joined the company. We work in infrastructure and buildings projects, some major projects, airports, and I have had the opportunity to work for a couple of very big piling contractors in the past, so my experience is relevant to the FUI.
Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullah. I'm Hamad Abu Hassan, the Geotechnical Department Manager at ACES Abu Dhabi. I've been serving with ACES over almost 26 years. ACES, as you know, it's specialized in soil testing and laboratory testing. We are specialized in doing all things under one umbrella, including geophysical department and topographical survey. Thank you.
Thank you, everybody, for the nice introduction. If I am allowed, I may start with Dr. Muhammad.
Thank you.
May I ask how can we better understand the advanced ground characterization, geotechnical investigation into practical decisions?
Thank you
making
for
while selecting most suitable ground improvement methods and the reclamation fields?
Thank you for the question. You know, with better characterization of soil, we will definitely reduce the uncertainty that we are countering or capturing in the soil that has a lot of variability. We often, in Abu Dhabi in particular, we deal with soil that is heterogeneous, reclaimed fill, carbonate soil, sabkha, and sometimes silty sand in the saturated status. So for us to capture all this, we have to start with the intensive geotechnical investigation, starting with the traditional borehole drilling with continuous SPT, accompanied by advanced tools such as CPT to capture the continuity and assess of liquefaction. Also, we do geophysical finding to check and predict on the lateral variability in the site itself. We also followed all this by lab testing on capturing retrieved soil samples by performing a different strength tested and stiffness to understand the soil mechanism. Also, a very important aspect that to keep an eye on nearby project that has already been conducted to understand what's happening in the region. So there will be no surprises when we are doing the investigation and we know what we expect to encounter. As I said, we keep an eye with all the focus on the current geotechnical investigation. With this geotechnical investigation, we are able to generate a robust model. Through it, we can identify the parameters that will be used in the design and to come up with a solid design. The design can assist us, or these parameters, in estimating settlement, such as in a soil that is subjected to compression or in heterogeneous. Moreover, we can assess in liquefaction, and then after that we can select the soil improvement if really required in that site in particular. So if we are dealing with a sand or loose material, maybe dynamic compaction would be the ideal solution. But if the fine has increased and we're looking at densification and drainage solving issue, we might think about stone columns. Then if it's more critical, where we are dealing with very soft soil and lacking of confinement, then we start to think about rigid inclusion or CMC. So to answer the question, really characterization is a very important tool to identify using the available data into coming with a robust model that will assist us in a design with a predictability that can be reliable on the long term. Thank you.
Appreciate Dr. Mohammed. Yeah, the soil characterization is the most vital and important to look at before designing, because all the designs are based on the first investigation, soil investigation, what we do, whether we do any boreholes or other tests that is being taken into account. If I may go to Mr. Tanawat, what is the single most impactful action that engineers, owners, contractors today can take to improve the effectiveness and sustainability of ground improvement projects?
Hello.
Yeah.
Thank you for the question. I think we all hear everything all day today that we try to overcome the conservatism, which is the same thing on this question. We all as a stakeholder need to come together, owner, consultant, and contractor, because before we design the ground improvement, we need to know what we decide for, why that ground improvement is needed. Because often, based on my experience, ground improvement is undertaken in order to just tick the box or based on the code requirement, etc. Often, I've been asked to design the ground improvement for some lightweight structure, which is if you look on the risk-based approach, you may not need it at all. Which is, I think, Engineer Omar already touched on that we need to look on the risk that we encounter before we design the appropriate ground improvement, rather than we need the ground improvement and we need to do it. That would be my idea. That
Appreciate. Now, going to the projects, let me start with Rahul. Have you encountered situations where more data led to a different and more economical solution?
Yes, actually, as in, I have two case studies in mind. Say, one of the case studies was a project here close by, I think in the Soba Heartland area, where predominantly there was a bearing capacity requirement for a building, which was in the range of more than 400, 450 kPa. And as a traditional approach, most people, when they're looking at this kind of bearing pressures that's required, the go-to solution of ground improvement is generally stone columns and something more rigid. But at the same time, upon looking closely into the soil investigation report, it was evident that what you say, that the rock mass wasn't too far away from the existing ground. And most soil improvement or soil investigation reports, even though would recommend this in order to achieve the bearing capacity, we as a contractor with our experience with sands and rocks did convey to the client that there is a way that you can maybe avoid stone columns altogether by just doing a zone load test on site. And upon creating the proper road base layer for doing the zone load test and carrying out the zone load test, we established that the soil, without any sort of improvement of stone columns, was able to achieve a bearing capacity well north of 600, 650 kPa. So going to say like a simple test, a load test, is also considered extra information that can be used in a project in order to enhance or avoid ground improvement altogether. Another example also is where, for example, when there was ground improvement with the requirement of vibro compaction to be done, and on site we realized the vibro poker wasn't going down beyond a certain limit. There was improvement required for about 6-7 meters, but the poker wouldn't move more than 2 meters into the ground. And then when we looked into the soil report, nothing about the soil report gave us that indication. So we carried out an MASW test on site only to find out that actually the soil is a lot more denser than what the SPTs of the site was giving us. Then upon closely looking at the full site with the MASW, there also we came to a conclusion that the soil is already dense enough for taking over the loads that it is required. So in both these cases, as you can see, like a second test gave us more idea of how the ground response, and we were able to remove the improvement altogether.
Appreciate Rahul. Yeah, as you have rightly said, the extensive need of extensive soil investigation does help in making the project more reliable and more economical at the same time, as you have said. Now, the time doesn't allow sometimes for the projects because of the rush and all, as we have discussed lately. If I may go to George and see his views, with the limitation on the ground investigation methods, how are the latest technologies emerging? How helpful these are? Do you feel how much value is added to the projects while you are on the projects, you are in construction, operations, doing the projects every other day? So could you tell us about it?
Thank you for the question, Mr. Shabir. First of all, what are the limitations of normal ground investigation? We have boreholes. The boreholes are localized. They are snapshots of the ground at a specific location at a specific time. In between, you don't know what happens. Engineers have to make assumptions, linear interpolations, which is what we all do, and it's fine. Then another big limitation is that normally ground investigation techniques are static and time-bound. So they are investigations carried out pre-construction. They do not allow for fluctuations of the groundwater level. They do not allow for the impact on the ground of the construction itself. So we have also to consider that, as Mr. Thanawat said, the codes sometimes, the municipalities, they want us to do specific prescriptive ground investigation. They do not ask more than a minimum level to proceed with the project. That's what we all do to carry on, get on with construction. So these are the three limitations I see. And then they create some gaps that have to be breached. With emerging technologies, we have got advanced techniques, like a few high-resolution CPTUs, seismic SPTs, geophysics. All of this, I'm not saying that we should not do normal ground investigation. I'm saying with advanced techniques, coupling normal with advanced techniques, you can have a much better understanding of the underground conditions, more dense grid, more dense data set, and more continuous. Put on top of this real-time instrumentation, satellite monitoring, and then you can have an understanding of the underground conditions throughout the lifetime, the life cycle of the project, not just pre-construction. Get all of this and put it also in a platform like a GIS and couple it with AI and machine learning, and then you can understand that you can have not only a lot of information, you can have very efficient information, very relevant information, very useful information. Ultimately, the whole market, the whole our job is moving from prescriptive and reactive ground investigation to data-driven and continuous monitoring, which helps us optimize projects, offer better solutions, reduce costs, reduce materials, and reduce carbon footprint.
Thank you, George. Great. Now, while we have discussed the use of latest methods to ascertain the soil characteristics before we design any building, any structure for that matter. Now, the current demand remains to use the sustainable materials, low carbon emission materials. So on that note, if I may go to Dr. Mohammed, I would say, what are the main considerations while using the sustainable binders, recycled material, and low carbon materials in the aggressive soil, and how useful those are? And how do we manage? Because at one side, we are looking to the environmental requirements of current time, and at the same time, we have to address the suitability in terms of the gaining the strength to the soil, basically.
This is a very important topic, especially when we are looking maybe at the underperformance of the ground also as well. Because sometimes when we need to look at a binder in specific, we have to see what the ground condition, how aggressive the ground is with the soil and the groundwater. In particular, in this region in UAE, in Abu Dhabi, the elevated chloride, an indication of high salinity, and the sulfate has a big impact on the concrete, and especially if we're using binder or even in the foundation itself, because it will cause expansion and then degradation on the long-term strength. So when we are looking at these parameters or binders, we need to check. We don't only look at the short-term strength, or we have to look at the more of a durability and other aspects such as permeability to assure there is no effect on the steel corrosion if there is a reinforced concrete or the concrete lifespan. So it's very important to understand the characteristic of the ground and properly interpretation of the data that we obtain from soil. Not only as we initially answered about the mechanism of the soil, but also at the durability in terms of chemistry to assure long-term project duration accordingly.
Thank you, Dr. Mohammed. If I may ask Rahul, while we have discussed, Dr. Mohammed has put light on the sustainable and the use of sustainable and low carbon materials. If you could change one aspect, if you could change one aspect of current ground improvement practice, what it would be, being on the project?
Sure. Well, the thing is, the practices that have been, established and put together, they're relatively quite sound. But one of the things that is kind of missing is normally when we start projects here, we are all reliant on the first piece of information, which is the soil investigation report, which is, in my opinion, quite abstract. And there is a lot of testing that is being done as per standard, but mostly after the improvement is done. Like if you were to look at ground improvement in itself, as in two major things that we are doing for ground improvement, one is to either increase the bearing capacity of the soil, or the other is to mitigate liquefaction. Now, if you look at bearing capacity, like I said in my previous case study, by doing a zone load test, which is normally done after improvement, by doing it earlier in the project, you can already optimize the whole design. So instead of doing it after, I would suggest why not do it in the beginning so that you can already get a on-field test data instead of just theoretically assuming what it's going to be. So basically, the suggestion here is, in terms of practice, do the test that you want to do post in the beginning and then come to a conclusion on the contractor level. Because before that, it's all just done from the soil investigation level. Then the other thing, when it comes to liquefaction, so most of the things that we get from the CPT, once plugged into the software, gives us a certain result. But most of the issues in this region is related to like the liquefiable nature of the soil is coming up because of the fine nature of the soil with silty soils all over. And the softwares that we use, and for people familiar with the softwares like Celic and whatnot, there is you have an opportunity to correct the soil based on the fine content of the soil. And the fine content and all the things about the soil are also missing in the soil investigating report. So all of these things, normally when we do ground improvement and then we see the ground improvement is not working, we then do all of these tests to establish why it has not been working. So if you were to do it in the beginning with softwares, and in the software if you can input like the fine content, the carbonate content and all of these things, you come to a much more efficient and optimum solution. So basically, with both these examples, what I'm trying to say is most of the testing is done a little too late in the project. It needs to start in the beginning and then use it to help enhance the overall design.
Yeah, that remains the limitations in most of the projects because of various reasons, what we know. I may go to Tanav. While we have discussed and Rahul has correctly put the examples of two of his projects where the soil was found literally more bearing capacity than what was assumed in the design. Have you encountered any situations where more data led to a different or more economical solution?
So I think I encountered pretty much the same experience with Rahul that oftenly you do various ground investigation, let's say CPT and SPT, and oftenly you see the discrepancy between the two. And most of the time you need to look in holistic view, as Rahul say, because CPT doesn't give you a file content. But when you do the SPT, you can collect the sample, you can test the file content. When you look in holistic view of both, it helps you to identify whether the liquefaction is a real issue to you or not. Yes, I encounter that problem quite often, that the more data you have, the more helpful you can identify the issues. Yeah.
Thank you, great. If I may go to George, we are from the same field. We are in construction and on the projects. If I may ask, in your view, what would be the most significant opportunity for transforming ground improvement practice in the next 5 years? What should we do, and what would...
What we expect to happen or to be more significant? Thank you for the question. So, as I said earlier, we historically, we have prescriptive and regulatory requirements for ground investigations. So, what I believe should happen and will help projects and the whole engineering, if it changes in the next few years, is to change from this setup to truly data-driven and performance-based ground investigation. We don't do ground investigation just for the fun of it or to tick boxes. We do ground investigation to help us with our projects. We are engineers, we want to think, we have to think, and we need useful information. So historically, ground investigations are sometimes, several times, conservative. Apologies to the ground investigation contractors. Take this to designers. We are also conservative, and all the projects suffer, the clients suffer, costs rise, material usage rise, carbon footprint, so we are not as efficient as what we could be. So with the advanced soil characterization and ground improvement techniques that exist nowadays, if they are coupled properly and in an efficient way, we can understand the ground better. If we can understand the ground better and convince not only the engineers and the clients, its authorities as well, like we cannot avoid that, then we can reduce unnecessary intrinsic factors of safety, make optimizations, offer better engineered solutions to our clients. Like I will ask as an example, how many of you have done pre-CPTs and post-CPTs in a project, and the post-CPT is not better than the pre-CPT? How many of you? Raise hands, please. Only 2-3 hands. Like I think there will be a bit, a few shy attendants. So this means that the ground improvement solution offered was not optimal, was not the correct solution. How many times there is a ground improvement survey, not the pre-CPT and post-CPT, and the post-CPT is not better than the pre-CPT? How many times have you encountered this? So, exactly. Correct. Yeah. So this means that the ground improvement solution offered was not the correct one, which means that the ground investigation done was not efficient, was not as efficient as what it could have been. So doing advanced, like following advanced techniques and doing a more efficient characterization, then you can offer relevant ground improvement solutions at the locations that are necessary and to the extent that they are necessary. So for instance, it is not good just to do ground improvement, like more ground improvement is better. We have to do as engineers, we have to do as much as necessary where it is necessary. This is the real transformation. And this will help projects and clients win in the end.
Yes, I do agree. We all do agree on that. I can understand how you feel from the contractor side. We are on the same side. But limitations remain. Sorry for interrupting the discussion. Now, considering the unique geotechnical conditions, if I may ask Dr. Mohammed, the unique geotechnical considerations, what conditions in the region, what key lessons should inform future guidelines for the ground improvement?
Lessons, huh?
Yeah.
Actually, I will go back to the same principle of integrating the soil data and not to underestimate the investigation and its importance, especially collecting the variety. And we are dealing sometimes in one area with a different zoning. So we don't have to stick to one zone, cover the entire area. We need to allocate these weak zones. This will help in terms to come up with the proper interpretation and what soil improvement to be conducted in that area. As Tanawat said, we're dealing sometimes with differences between SPT and CPT. The wise decision is to have a look and combine with the geophysical and the laboratory testing. For instance, sometimes to confirm what Mr. Tanawat said, carbonate soil give an indication of high CPT. But if you check it in the lab, it is showing that the stiffness is much less, especially if you use triaxial. So we need to look at all the data together and trust the soil report and the investigation with the collaboration of consultant. Thank you.
We do trust, of course, and we are not challenging any of the methods, but sometimes the feelings come up, being contractor and being hammered every time. On that note, I may go to Mr. Tanawat. What are the most common causes of underperformance in the ground improvement projects, and how they can be avoided, basically?
I would think George has already mentioned about it. Basically, we just have to do enough investigation, but the point is when is enough. As a designer, most of the time you've been forced by the process, by the program, by the time and cost to do just what the authority require. The more stringent investigation come, as Rahul say, during the execution or during the construction process. I think it's a time maybe we need to work with the client to bring the contractor on board a little bit earlier in order to facilitate this, because that would bring the value to the whole project instead of try to leave everything to the last end, let the contractor deal with it.
Yeah,
I think that would be.
We all agree that we should be communicating more on this to the clients.
Yeah.
So I may ask Rahul, how should uncertainty communicated to the clients and stakeholders while evaluating different improvement options or procedures?
Well, I think this so-called thing about uncertainty among us geotechnical engineers, I think it's a very obvious thing. Soil as a material is heterogeneous, and heterogeneous is a direct function of uncertainty. So among geotechnical engineers and engineers related to soil, they all are very much aware of it. But if you want to convey this to our stakeholders and client, you're explaining this to a layman, and for him or her, all that matters is time and money. So uncertainty is also going to directly affect the amount of cost and duration that the project's going to take. A simple example, like most soil reports, as in they are covering full ground. So maybe in a project, if you have 10 boreholes and say 9 of them are showing that the depth of improvement is required is maybe 5 or 6 meters, and then one of them is showing that you need to go up to 9, the general statement that you will find in a soil report is the depth of improvement required is 9 meters, because they have a blanketed statement just to cover the whole thing. Now, if you take that to the client and say, okay, the soil report says 9, so we're going to do up to 9 meter improvement all over, that means the uncertainty or the variability in the soil is not fully captured. You're just going for a very conservative approach to solve the problem as per the soil report. So, but this same thing, if you were to tell the client, he would not understand it. He's like, oh, the soil report says 9 meters, you have to do 9 meters. But another better way to make him understand is, if you're doing only 5 meters for 90% of your project and only doing 9 meters in one particular location, you're going to save this much money and time. So then all of a sudden he's like, yeah, why don't you go along in that direction? So basically, to answer the question, uncertainty to the client and stakeholders need to be conveyed by showing that if you were to consider the worst case scenario, the whole project is going to be a lot more expensive and going to take a lot longer, in my opinion.
Yeah, we totally agree. Please bear with me, and with Rahul as well, with all of us. If we have hurt anybody's feelings who are from a client side or the designing part, my apologies for that. But we are expressing the practical and day-to-day issues what we are facing. On that note, if I could go to, we'll come back to you. Of course, after this, I will put, if I go to George and ask, could predictive analysis eventually optimize ground improvement selection? This is the last question.
Can you repeat, please?
Could the predictive analysis, what we predict that it should be the analysis to be done, eventually optimize ground improvement selection? And if that, or will engineering judgment always remain central? And as we discussed that the soil investigation is done, the design is done, and we base our assumptions on certain things. But the more prediction on the experience and characterizing the soil, if we go to the client and say, like Rahul has said, how far it would be beneficial for the project, if we could.
Yes, of course. So every site is unique, and the local ground conditions are unique. There is a lot of uncertainty, and we have to deal with this. So the engineer always has to think, and we always have to see every site with as much data as we can. It is not only data, it is not only ground investigation, it is also historical data, it is data from the neighboring plots, it is project constraints, it is constructability issues, it is a lot of other factors. It is risk management, it is commercial issues, contractual issues. So the engineer has to think and to take into account all of this. It is not just data. A lot of data is good. Good and efficient data is better, but the engineer always has to put his mind into work and think all of this together. Today we use a lot of AI, all of us. I use a lot of AI. Everyone should use a lot of AI. If you don't use AI, you are left behind. You cannot solely rely on AI. You can have a lot of data. You can do data crunching. You can have it analyze trends for you. You can have it compare alternatives. You can have it propose solutions. But in the end, you are the engineer. You have to think. And this is from ground investigation to like potential ground improvement solutions. Not only ground improvement. It can be piling, shoring, and be any engineering solution, and the use of AI.
Yeah, we do all agree that such methods not only save time in the overall project, it saves money for the client, for the stakeholders, and gets a better project. On that note, we are coming to the end of this discussion. I may leave the floor to the audience. If anybody has a question, you are welcome.
Thank you, colleagues, for the fruitful discussion. I'd like just to, being an old guy, to highlight some issues related to the topics. One of them is what Mr. Rahul spoke of. At the beginning, I would just embarrass him a bit by saying, are you a geotechnical business company or piling company? Put this aside, not now, later, okay? This is number one. The reason why, because if you work with geotechnical engineering as an industry, it does not necessarily mean that you are a geotechnical consultancy or you can do geotechnical consultancy. The issue is related to the saving you made on one project when you introduced the zone load test as a proof of the goodness of the ground to construct on. I would say that still the zonal test is a localized test whatsoever. It cannot, sometimes I'm not a believer of the geophysics. Sorry, of course, for people who are in that industry. But we still need to do it as a kind of, counter-proof of that we have not missed any possibility, or we would not regret it if at all it had given us certain information. So I would say zone tests need to be carried out in collaboration with different other tests. As Georgios was trying to say, it's an integrated investigation. It would start from seeing what others were troubled with, from the neighbors and also all the data, and then you get into starting your own investigation, guided but by what really physically happened to others and what others have gotten. Moreover, and I didn't come to the issue, moreover, when I test, I perform a zone load test, I should understand what kind of implication for the load and deflection I am getting against. Suppose you've got a ground that is strong, as we have, everybody knows in the SPT, right? You may have a very high SPT. Why? Just because you've got some gravel. It does not mean that, your site is strong, right? In the same sense, if you make it in a zone, it may not be just the length of gravel, right? But the strength, the toughness that you are getting sometimes is related to cementation. So the groundwater plays a very important role there. So if you are testing zone load test in a dry condition, be careful, right? So I'm just trying to, like widen the discussion for the, younger guys and those who are really, who are doing some work based on their knowledge, which may slip them into troubles. You got my point? The same thing happens also with the swelling soil. Swelling soil has a very strange character, you see. When you inund and test, then you can get the swelling offsetting the load deformation, right? But on the same time, you would say, deflection very good, strong ground. In fact, while the deflection is not large, especially in the middle, in the confined area, if you test the swelling soil, the bearing capacity is much compromised. Meaning that ground, if inunded with water and loaded, it will fail in bearing capacity. While it gives you a first very good impression of deformation. And then once it fails, deformation will come later, but a plastic, not elastic deformation, because it already failed, okay? I will come to second point quickly. Sorry if I'm delaying. For CPT testing, for example, I had hoped if I would have, heard, I know many people are knowledgeable, I can guess, of course, are knowledgeable, met with many conditions, but I would say in testing CPTs, one of the, apart from the possibility of having angle or, these kind of things, you may get a premature kind of refusal, right? And you can't do anything about it in CPT. So combination of SPT and CPT are necessary. And clients should understand that. The first point, when I spoke to Mr. Rahul about doing something that is not much within your scope, is dangerous, I would say that this has been done or is being done systematically by structural engineers. Because structural engineer knows Young's modulus, Poisson's ratio, right? He doesn't know the material. Material has its own problems. Swelling, collapse, washing, chemical or mineralogy, the material itself may encounter volume change not based on mechanics or hydraulics, as we know. We know volume change is mechanics and hydraulics, but it may be chemical as well, right? So the issue I'm raising is educate your structural engineers. Guys, you're getting into a dangerous area. It's not yours. I can guess someone like Georgios, for example, I feel he's from construction background, but he's very knowledgeable about geotechnical engineering. But should I trust him to do geotechnical consultancy for me? No, it's not his role even in his company, right? So, I was amazed by his discussions, okay? Very, very, he's to the point, he knows what he's talking about. So I would say CPTs should be combined also with SPTs. I don't want to be very specific here, but I want to say there are much of challenges. When you, for example, try to apply a certain liquefaction calculated criteria to apply on site. We had here, historically, a rule called 468 for the first 4 meters, and then second 4 meters, and third 4 meters. 4, 8, 12. To mitigate the liquefaction in Dubai, where the acceleration of the intensity level was 0.15 G at certain point of time. I know it's kept changing. I don't recall exactly, I mean, what is
We appreciate, highly
I'm sorry.
appreciate your time and your
I'm
advice.
sorry, I prolonged.
This is a subject that has a vast, that can be discussed days, months together. And characteristics of the soil itself is a vast. The geology itself is a separate, then we go to the investigation, then we go to design. Appreciate your advices, and all we have discussed the same thing.
To raise some messages.
No, I mean say, when we discuss, it's always a healthy discussion, irrespective we agree or we disagree on anything. This always gives an insight. Thank you so much. If any other questions from any other colleagues, otherwise we take the leave. Thanks so much for bearing us for this half an hour or so. Have a good day. Thank you.